I am not Joe, I'm the guy on the right. So Joe was the one that came up with the plan for this session, by the way. Joe unfortunately had a kind of a medical emergency in the family, wasn't able to make it today, so I'm doing his half of the deck, or as I like to call it, his quarter of the deck, because I made the TPC-DI a little longer than was originally intended, since that's the one I know better. But in the end, he actually does a lot of the benchmarking within Databricks, and so a lot of the charts you see this week actually come from him. So his day job is actually to work at benchmarks, whereas my job is in the field working with customers. But I do spend a fair amount of time doing some benchmarking and tests myself, so I thought this was a cool session for us to give. But in the meantime, let's get Joe out of the way here. Joe is the adult in the room usually, but since he can't make it, we can actually change the name of this session unofficially while he's gone. So in the end, what I'll do is I'm going to try to speak as agnostic as I can on a lot of the topics we're going to go through today. This is the second time I've gone through this session. I did it yesterday morning, but it was extremely full. They asked to do a repeat session, so I get everyone who here is glutton for punishment and can't go to enough sessions in a day and can't get ready for the party. But I still hope to see everyone at the party tonight. I did bring an actual pair of sunglasses because there's actually sometimes I'm going to throw on the Databricks sunglasses. So I'm speaking from the Databricks persona because a lot of these we just do really well at, and so it's hard for me not to describe what we're working on. So you'll know when I'm changing personas. So the original session title opens up a tremendous amount of scope. So before moving on, let's narrow the focus of what we're talking about. And in fact, I was speaking to a colleague this week who reviewed the deck and made me realize that I'm not actually first referencing what we're actually covering, because there were a lot of questions about what customers value and external factors when choosing platforms. So I'm going to start by pointing out that what we're looking at are really just official benchmarks. How do you choose great or focus on what's important types of benchmarks for narrowing down how good platforms are. It's very black and white. Okay, everything should get a metric that's very standardized, how fast something is or how much TCO it's going to cost, but the decisions around which platforms to choose are really just more of a customer-based decision and are often decided by external factors. So what we're going to do is we're actually going to start with the Lakehouse side. All right, so the Lakehouse benchmark test. 1 second here, make sure this thing is not okay. Nope, there it goes, still going. So a Lakehouse benchmark would test everything about ETL and SQL, okay? Whereas more on the AI side, what we're actually looking at is, how do we focus on what's great for either kind of the narrow-minded focus on AI benchmarks versus, how do I maybe test something more macro or like an end-to-end type test, okay? But the AI benchmarks actually deserve its own hour session by itself at least. So we'll see if I can actually get to it, because yesterday, I think I looked down, it was 1 minute left, and it was like AI benchmarking, so we didn't get to it yesterday. So I took a screenshot of this blog because actually I just thought it was funny. If you type up benchmarks and search for it in Google, you kind of get a blog that starts like this. How many people are as cynical about benchmarks as this guy? Probably a lot, right? Over the years, and with enough warping of benchmarks to suit one's argument, the community has become cynical of advertised benchmarks by different platforms. So if everyone's cynical, though, why are platforms and companies still doing benchmarks? Why do people show up to sessions like this? It's because there is some value, and in fact, even in the keynotes, they talk about benchmarks here and there, right? About being a way that you can standardize on different tests, right? Gives kind of this level playing field for all platforms. So this standardization and repeatability is important. Okay, we want to be able to conform to the same practices. There's kind of this scientific method of this approach. And the best benchmarks are defined and constructed by expert practitioners that are able to align those tests with modern data practices, data modeling, patterns that then leverage sensible evaluation metrics to score those platforms. However, there's a lot to not like about them too, right? Everybody's cynical when you see one because it's kind of this fake news approach of it, right? There's no benchmark police to come around and arrest anyone by publishing a benchmark that's just not taking into account everything or maybe misleading people, right? Just as a quick test, I did this one yesterday though. How many here have heard of the TPC-DS? Probably most of you, right? It's the one they most often cite. Stop, I know you have. Does anyone know how many organizations have ever submitted an official benchmark to the TPC for the TPC-DS? No one? It's 4. 4 total organizations have ever submitted a benchmark to them. But we all see these benchmarks about TPC-DS all the time, right? This is how this platform does, or Databricks will benchmark everyone and say, hey, this is how everyone does, right? But only 4 have ever submitted it. So it just kind of goes to show you about how difficult sometimes it actually is to get an official one, and which, unless it says it's official, you probably should take it with a grain of salt. Now, by the way, the 4 that have are Alibaba. They actually have a couple. H3C, Supermicro, and the 4th is Databricks. So while I'm talking about lakehouse benchmarking, these are really just trying to say what we would kind of include in a lakehouse benchmark. A lot of times you could even maybe say AI would fit into that too. We do try to say there's lakehouse and there's AI as a side of it. But in the end, lakehouse is that ETL, that data engineering, the SQL consumption. So all the pieces that you'd want to do in an end-to-end lakehouse platform, right? So the biggest one most people hear about is the TPC, which apparently lost one of the P's in their acronym. It's actually the Transaction Processing Performance Council. Their whole goal is primarily focused on 2 organizational activities. So to create good benchmarks and create a good process for reviewing and monitoring those benchmarks. They want to be the benchmark police, right? So the TPC doesn't just operate in just one arena. This is just the active list of the benchmarks they have. And obviously for the sake of time in this session, we're not covering everything. But these are the active ones. They actually have inactive ones. There's multiple versions of some of these as well. Our focus will be on what are known as the decision support benchmarks. So that's the DI, the H, and the DS. So right now I am narrowing scope of a 40-minute talk. Hope you guys realize that. There are others though. I'm gonna at least mention them in case you ever want to check them out. There's the star schema benchmark, okay? And there's the ClickBench. So star schema is commonly designed by for business intelligence tools. So this benchmark focuses on just SQL performance that would commonly be sent from those BI tools. And then ClickBench is, they call it the no join benchmark. It's very niche type of benchmark, tailored to scenarios like clickstream analytics where joins might not be prevalent. So it's more common when evaluating systems for specific analytics applications where simplicity and speed are paramount. All right, 10,000-foot level. This is what we're focusing and suggesting that we'd like to benchmark with the Lakehouse benchmark. So a theme here, and what I'm trying to come back to as we look at a lot of these slides is, the community and industry really needs something that does kind of encapsulate the full gamut of the Lakehouse. We need a full end-to-end benchmark. So as we're looking at a couple of these, you'll realize that there's ways that you can kind of skirt the rules or take shortcuts on some of these benchmarks to help kind of suit the needs of just that portion, whereas organizations and decision makers need to actually evaluate more than just that narrow focus that's under the microscope. So the first benchmark we're going to dive into is the TPC-DI. There's no SQL consumption in TPC-DI. Then there's the TPC-H and DS. We're going to combine those into a group too. And there's no transformations in the TPC-H or DS. So you guys sense the problem. So we'll start with the DI. This is the part normally, actually, through this section would have been my section to talk about, and then I would have given it over to Joe. But I have the ability here maybe to expand some of this, as I know more about this one than the other ones. This is the ingestion and ETL one. So as of today, it's actually never had an official submission. So the DS actually has 4 more organizations that have submitted than this one. So it likely never will have any submissions until they update it to allow for the calculation of total cost of ownership metrics for the cloud. So it's very focused on infrastructure costs and a lot of different things we're not going to get into today. But we actually built this a couple years ago for the first time, and we weren't able to submit because we can't get it scored. So it actually brings me to another issue I have with a benchmark like this, is that, when I first presented it 2 years ago, the talk was mainly focused about what did we learn? What are some of the things you could take back, as attendees here to the conference? What can you take back that you could learn and put into your applications? What size were the best workers, what configuration was the best workers, what node types, whether or not photon was valuable. There's a lot of things like that we were trying to include, but in a vacuum, we have no way to compare a competitor if no one's ever submitted the benchmark before, right? The main thing is I'm actually going to give you like an extremely short TLDR. There's somebody in the room who also had to code this on another data warehouse before. He knows it's pretty complicated. So they actually just give you nothing but like this huge 100-page document. It's actually over 100 pages of PDF of just business rules. So it's probably part of the reason why no one ever coded it. So you get business rules, you have to code all the business rules and pass audits into all these tables, okay? So there's raw data with text, CSV and XML, and then there's transformations that all go into different, medallion layer tables, bronze, silver, gold, okay? So for each of these benchmarks, I'm gonna kind of go through, hey, is it valuable or not? Is there anything we can kind of glean from it? This is the best official ETL benchmark available in my opinion, at least the ones that I know about. Unfortunately, this is the worst official ETL benchmark I'm aware of, all right? I know it can be confusing, but I will explain. Let's start with the good news. It's actually very well thought out, all right? It's very early 2000s data warehouse type approach, okay? Even though I think it was released later in the 2000s, I think like 2009 or something like that. But well thought out data model and use case perspective. It's focused on stock market data. The business rules make sense. They match what customers commonly do in production, even with incremental batches. The raw files are common semi-structured data types. Would have liked to have seen JSON instead of XML, but beggars can't be choosers. One of the bigger gripes actually about it, with the fact that they don't give you any code, you could turn that into Lemonade and say, well, if they don't give me code, I can actually write code that's very tailored to what my platform does very well, right? So that could actually be a positive in some ways. But is the worst? Well, first, mainly because I don't think anyone in the room could probably name another ETL benchmark out there, right? There's nothing really we have to use to compare, all right? And this thing is extremely frustrating. I've struggled with this thing for 2 years now. So I have a very love-hate relationship with this benchmark, but we've turned it into workshops. We've turned it into trainings. In fact, if you were at the workshop this morning for the Data Warehouse in a Box workshop on our new test drive that we're calling it, like the full serverless experience, it was all built on this TPC-DI benchmark, right? We've implemented it in multiple different ways. The official submissions also mean we have no way to get a comparison, so we're still kind of in that vacuum. And this is where I would love for partners or other platforms to benchmark this so we can kind of know where we are. We actually eventually did was we converted it to DBT for the orchestration and just used our SQL code, and it allowed us to test it on different platforms without having to recode all the orchestration piece to it too. All right, so again, this is the part where I'm gonna throw in the sunglasses, okay? These are my Databricks shades, all right? So I'm not talking agnostically for the next 5 minutes or so. So why are we gonna spend more time on this benchmark in particular? First of all, because people come to Summit and they want like expertise in certain areas. So I know more about this benchmark, unfortunately, than most people. So I'm gonna talk a little longer about it. Second is the TPC-DS, we've beaten that thing to death for years. There's not much new that I can add to the conversation today that hasn't already been stated. And because Joe's not here to adult and I have the clicker. So 2 years ago, I think on level 3 over here, same building, we announced that we had finished it. Key things, and I'm gonna try to hurry through some of these slides so we can get to the AI part, trust me. The key thing here is that what we evaluated and got from this slide, this was an actual slide from that session, we had gotten this down to $1.51 per billion rows. So I use a heuristic here for cost, okay, price per billion rows, because we can't produce the actual metric that they use, but the intent of that metric is how much does it cost per row, okay? So there's different scale factors for different size data, and if you're amazing at a low scale factor, you can get that price per row down great, you can submit that benchmark. But most of the time you get economies of scale, so you wanna run a bigger benchmark so you can get more rows done, right? We were down to $1.51. Now the big thing that I liked at the time was we're almost at the same price as non-photon. All right, get your job done 33% faster, goes from 36 down to 24 for only a little bit more, 7 cents more, right? That was a big deal to me. I'm like, oh, well now that makes it great, right? People buy sports cars for a reason, right? They're a little bit more, they're faster. I think, beginning of last year, I think it was April, a couple of colleagues of mine, Franco Patano and Dylan Boswick, we actually published a blog because then we converted it and actually got it coding in, or working in Delta Live tables. So this blog was pretty well received at the time, but we'd gotten the price down to less than $1. Great. The reason why the Delta Live tables one worked out so well was because it did have good orchestration and kept the cluster very busy. But Photon also made some progress by that point, so it was actually working out pretty well. This is a video I showed actually at our tech summit this past year, because we had actually, we turned this into a workshop at that time too. So during this data engineering workshop we had, or training that we had with everyone at Databricks and some of our partners, what we did is we took the DBT version and recorded it running on several different warehouses, just to show the same code running on multiple different warehouses just using DBT. Now, ideally, this is where like the provided code gives you some value. I can't say this is how long it would run if someone who was an expert in BigQuery or an expert in Synapse or an expert in Fabric, how fast they would get, right? I just use the same ANSI SQL code that we're using, and hopefully it's pretty similar. I don't think it's probably too far off, but this is what we were getting when we ran the same code through. The top right, we actually, and this is the Redshift one, I didn't record this. The person who recorded that one, their timer or their video stopped recording at about now, I'm gonna say, it's just over an hour. The measurement was still running, so luckily EMR, or not EMR, but Redshift doesn't care that his video stopped recording and it still completed the benchmark. We know how long it took, it was an hour and a half. But in the end, this was kind of a little bit of validation about how far we're getting. And at this point, we had actually tested this now on 3 different tools, right? Our traditional clusters, we did it on DLT, and now we've done it on Databricks SQL, right? You can't see it, I think it's behind the closed captioning here. I didn't know we'd have closed captioning. But this is 1179 here, and then it's on the left, I think it's 1758, okay. Right. So our price per row is now down to 73 cents, okay? At this point, by the way, by the time we got to the DLT version, Photon was cheaper. There was a cloud data warehouse missing. Anybody notice that? So we did try this, and I know there's someone in the crowd who knows that cloud data warehouse is terrible at this benchmark, because he tried running the code for him. In the end, there's one that was missing, so just to try to point out before anybody comes back and say, oh, he didn't test that other warehouse. We tried, but we also didn't want to test on the 1,000 scale factor because they can't, it was really difficult for them to even do the 1,000 scale factor because they're not able to really handle large files very well. But in the end, we also had another partner who wrote a blog just on the 1,000 scale factor, pointing out that it was 60 times more expensive just to run that 1,000 scale factor. So the previous video was the 10,000 scale factor, which is a terabyte of data over the, I think, 400 or 500 files. So this one is only 100 gigabytes of data across the 400 or 500 files. I think Databricks was 10 times cheaper to do the 10,000 scale factor than they could do the 1,000 scale factor. So 10 times cheaper to do 10 times more data. So how does it perform today? So I took basically where we are today. This is where I'm actually most part of where we are. We've gotten this thing down to, this says 10 minutes and 44 seconds, okay? But in a second, you'll see that we ran that on 1/4 of the cores that we used to. So we went from 576 cores down to 144, okay? But we only slightly increased the time. The goal of the benchmark is to have the lowest TCO, not the fastest time. So the best TCO for us at this point was running it with only 144 cores. So we also wanted to expand it a little bit. We've been running with the DBT approach. So we said, all right, well, what if we test it in EMR? Take the same Spark code, let's just run an EMR and see how fast it is. So the right side, this is our, if you've ever been to our workflows, you see our timeline view. That's what the timeline view looks like. It's kind of a cool way to see how long each of the different tasks are running in a quick little snapshot. Whereas, here, this just, I charted it. That's all it is. So in the end, it was 55 minutes versus 10 minutes or so. And they had 55% more resources as well. So I think they were running with 224, we had 144. Now, EMR has a dirt cheap SKU though, right? So that was why it's pretty important to say, all right, well, you can get the cheaper SKU, right? Photon has a multiplier, right? So I think with Photon, you're probably looking at the unit price is probably several times more expensive. But when you're basically running 8x performance over them, you cut all that compute cost out, and we actually ended up being 3 times or 4 times actually cheaper than they were. So why did we get better? We're going to summarize through this again. This is kind of the chart over time. We're about 7.5 times cheaper than where we were just 2 years ago. All right, I'm probably a terrible coder, at least used to be. Maybe I got better. Okay, we did update some of the code to make it run a little faster here and there. But Photon got full coverage now. We used to not have full coverage for this whole benchmark, and now we do. So now I think we're down to 20 cents, whereas we were $1.51 before. So H and DS, moving on to SQL. Let me take these sunglasses off before I fall off the stage. All right, back to my agnostic persona. All right, the H is the oldest, all right? If you've ever run these benchmarks or know anything about them, the DS was supposed to take the place of the H. It's the middle child between the D and the DS, okay? It's still roaming the earth like a zombie in the night. It was only available for a year before the TPC started planning its replacement, since they already saw OLAP trends changing. So it took a while before the DS actually got here, though, but it was only out for a year before they realized they needed to change it. So how was it constructed? It follows a third normal form approach, very Bill Inman style of warehousing model with only 8 tables. One of them was very large. It has a limited data types that are in it. It's so much easier to tune than the DS, but it's actually so easy to tune. One of the issues were that we're gaming it. A lot of platforms were gaming it to get it super tuned and even get perfect index coverage. It was also not very demanding on the SQL optimizer on those platforms. The only real complex requirements of the optimizer is join reordering and predicate pushdown. So what about the DS? All right, it was initially commissioned to be built 1 year after the TPC-H. It took 12 years to finish, though. Most have heard of this benchmark, but the wild exaggeration of test results have been a driving factor actually in the community glazing over the platform results. So it also introduced mechanisms to try to prevent much of that over-indexing and gaming of the benchmark from the H, but that only led to a lot of platforms just disregarding those parts of the test, right? There's even a data warehouse out there that publishes their highly tuned version of these tables with their deployment, so people can go run the queries on them. But that's not the real benchmark, right? Much more structured than the H. It abandons the 3NF approach, okay, to be more BI-centric star schema, or what they call a multiple snowflake schema. Really does, it actually is a very good benchmark, okay, for what it's doing. The problem with it is that a lot of organizations kind of skirt some of the rules around it, some of the data generation and maintenance pieces, right? Or some of the data loading and maintenance pieces that are. So this was actually the third time they tried to create this decision support benchmark, and they really did get it right on the third time, okay? Excellent. If you ever go read blogs about it, and I read a really good one about it in preparation for this, they really took a lot of thought into how to create the data set and the distribution of the data, and making sure that they're getting very dynamic ways to get some of the filtering and pruning, the way that they set up, the ad hoc versus the BI type queries that you're going to run. They're all pretty good, very good. So this deck is actually going to be available after Summit. So this is kind of that one sheet, kind of cheat sheet if you want to take a look at it as well. So is it valuable? We went through this with the DI earlier, right? So some believe the TPC-H still has a place, but I'm kind of in that camp. I don't know if you can tell so far. The TPC-DS, should have rendered this benchmark obsolete. Okay. If you want to get a quick and easy benchmark running in a simple fashion, though, this can do it. Okay. For modern workloads, it's too easy for platforms to tune them, specifically for the data and operations. My suggestion is when a platform touts their TPC-H results, ask them about their DS results. And in fact, it might actually be a red flag that if that's the first thing they lead with, right, their TPC-H results. So the DS, again, I mentioned it earlier, third time was a charm. Excellent job at structuring the DS with how the data is actually loaded. It's complex enough to capture modern operations. The data and queries are well thought out to be, to value dynamic pruning. It balances ad hoc queries very well with the BI queries as well. And it's if you have a platform query optimizer that can handle the DS, then organizations can probably feel pretty comfortable that it'll handle pretty much any query that it'll throw at it. You know, it does bring complexity in setup, okay? It takes a little bit of extra time to make sure the data generation's loaded. You got 4 different parts of this to kind of like run in tandem with each other. There's also the extra stages. Those extra stages are things that, you know, a lot of platforms will just disregard. You know, the data loading is part of the step. In fact, part of the point of what we're trying to say is that you can't just only look at SQL. If you're just disregarding all the time it might have taken to actually index that data, right? So, I mean, I wrote this part of the deck on the plane, by the way, on the way here. So before moving on to AI, though, you know, is there a way that there can be something like a TPC-LH, right? So far, we talked about the benchmarks incentivized only doing that narrow segment that's being tested at that moment, okay? So to counteract that, you know, put the whole end-to-end lakehouse under test, all right? So that now it has to value the data layout. It has to value, you know, how it's doing transformations from a data engineering perspective, okay? It has to value how it's going to be consumed and if data is actually getting updated and changing while you're running queries, okay? Ensure that all benchmarks have metrics that account for all possible platforms, right? The TPC-DS didn't even allow for cloud-based operations until we worked with them so long, they finally approved it and we were able to submit ourselves for the DS several years ago, right? The DI and some of the others still don't allow for it, okay? So having it, kind of making sure they're staying modern is one of the big things. In fact, it's actually the exact opposite problem with AI benchmarks. I think that, you know, once you see this deck, or we hopefully get to it, I think that last year the Stanford report, or this year the Stanford report removed 15 benchmarks just this year, and all of them have been created within the last 4 years, and then added 18 new benchmarks. So the AI benchmarks are just insane right now. There's just so many. It's just trying to make sure they're keeping modern. So last year, actually, the University of California, Berkeley published this white paper where they suggested a lakehouse benchmark, but they're not an official entity. They use the TPC-DS as the raw data, which is still a great data set, but some of the community may want to move past that. But during the, or composed of that 4 tests is really the TPC-DS, but also a refresh, you know, a merge micro benchmark, and a large file count. It's a step in the right direction, but what we want to do is actually get to more of an official one that the community can embrace. So how would a balanced lakehouse benchmark work? So this was my concept I was trying to get on the plane, right? If you were to create a new one, what would it have to look like? You know, you would have to be able to have a balanced number of queries and query time. That query load has to at least be as much as how long it might take to optimize the data, right? So how would this type of test work? So we wanted to work through this thought experiment, and I used the TPC-DI since it's a lot easier to take something that already has an ETL and just add SQL to it than doing it the other way around. And also because I know it better. I'm biased. So here I took the same job I showed you earlier, 10 minutes and 44 seconds. I actually think I ran this one on an interactive cluster, so I'd get an exact number so you knew how long it took, okay? Rather than starting it on like a workflow with a jobs cluster and making it, you know, have to wait 2 minutes for a cluster. When I ran this version, I did adjust it because I did run it on an actual jobs cluster, so it took a minute or two for it to go up. So this one has an optimize command after every single major fact table. So I clustered every major fact table and ran an optimize command just to see how long is this going to take, right? Every platform is going to face some extra time on this step. How do I keep it indexed, right? How do I keep it tuned? So it took us about 44% more, all right? So it was $4.92 on spot, $6.42 on demand for the 1 terabyte data set, all right? Before anybody thinks that this is actually too expensive, that price with us optimizing the tables and having stats on all the tables is still half the price of EMR, a third of the price of BigQuery, and at least 15 times cheaper than any other warehouse. Except at the end, you actually get optimized tables instead of just loaded tables. So out of curiosity, anybody think it's worth it? The same number of people who raised their hand yesterday, actually, 0. So nobody thinks it's worth it. It's kind of a trick question, right? It's only worth it if you save money on your query side, right? If in this case, it wasn't worth it because the TPC-DI has no SQL query, so the total savings is $0, right? So if you had a benchmark, or if you were in an organization who actually were consuming from these tables using Databricks, or if you were using any platform and you were trying to use that one platform for everything, you want to save money on your SQL side to make it worth this step. Make sense? So let's think about how we would balance that for this benchmark. So at this point, we kind of need to save $5, right? There's about $5 more. So one cool thing is, so we're going to review what we got for our money. What do we get for that 44%? So first of all, I'm showing the details tab from the same table on both sides. So on the right side, you don't see any stats. Left side, you see a whole lot of stuff. You probably can't read it from there. But those are all stats mostly. They're all stats for all the columns. In addition, I pointed to the columns we actually clustered by. It's basically the symbol and the date. These are surrogate keys of those, though, since that's how this benchmark works. So how does our tune table now help us improve SQL consumption? So take a look at two different types of queries that could be commonly launched. We're going to take a look at ad hoc type query or a BI type query. Okay. So first, we're going to review an ad hoc type of query to take a look and see what we got for performance. And this one's for the stock details for a single day. Okay. This is the dem trade table. It has every stock trade made in this dummy set of data. Okay. This is every stock traded, what day, who was the salesperson, what time did it close, how much was it for, did they use cash, was there a fee or a commission, whatever. It's all the details from that. But an ad hoc type query might want to say, I want to find this very specific one, okay? I want to go to this certain day, and I want to pull all of them that were for a single symbol, stock symbol, okay? Well, here what we got was we actually read two files. We read 0.07% of all the files. It was like 170 files, I think, right? We read two of them, so 0.07%. Whereas on the bigger or the non-optimized table, we read 75% of the files. Again, I was on a plane, and I think that my results might look weird I think we have weird stats on the total data, but I do believe in the total files read. So it was 448 files and 155 that were only pruned. So 600 files, 448 of them read. So we had an excellent start. We had a 30x improvement in time, right? That's great. What if we had a BI type query? Now, I love this query, by the way. I had to write this from scratch. I purposely tried to pull a table that I didn't write any filter on the table, right? So think of like a Power BI or Tableau, any type of BI tool. You have to write a query that you only use dropdowns, right? Dimension tables, okay? I want these very specific things. So nothing in this query hits the fact table explicitly. It only uses the dimension tables, and it doesn't even join on the dimension tables by anything we filtered on those. So it forces kind of this dynamic pruning approach, right? So what we got was this particular table. Let me go back. I skipped past it. There we go. So we got 20x task time improvement. All right, it went from 13.82 seconds to 4.4. I disregarded the wall clock time because I think we had some contention on this warehouse that was shared. So, but the task time, you can definitely tell the difference. All right, we still got, I think, 4 or 5x on the wall clock time too. But task time, we definitely went down by 20x. All right, but this particular query shows you that, all right, well, even for these types of BI queries, we're getting much better. All right, so you could probably call this one conservative 4 or 5x. So how do we balance, right? So right now we need to assume that there's a 2x. Let's just conservatively assume 2x performance gains. We need to make it 5 minutes. This math basically tells us that it would have to be a 10-minute test where you didn't have optimized tables, which would result in a 5-minute test if it was, because you have your 2x. So we've saved our 5 minutes, right? That would have to be how this thing gets balanced out. Oh my God, I made it to the AI one, which I know the least about, by the way. Actually, did Avi leave? Avi helped me on some of this, by the way. So. Okay. Why do we benchmark in AI ML? It's basically the same reasons we were benchmarking earlier, okay? Same exact type stuff, right? We want to have the same standardization, across different platforms that we were getting with data engineering or SQL, okay? ML practitioners care about different things, and they only need a single subset of the full end-to-end ML development and deployment, and that's what makes them different. So We cared about the full end-to-end with Lakehouse benchmark because you have to do kind of all those steps. To get to SQL consumption, I need to do everything before it, right? Well, in ML, I may only care about, inference at the end. I may not care about training. Make sense? So the goals and objectives, there's the performance assessment. We want to evaluate key metrics like given model speed, accuracy and efficiency, resource evaluation, assessing the model's impact on critical system resources, including battery life, memory usage, and computational overhead. We want to have validation and verification, so you can check the accuracy of an algorithm and want to make sure that it's actually measured against something that's external that you can actually validate is 100% correct. Okay. Competitive analysis, compare solutions against competing offerings in the market. Credibility, so you want to make sure that accuracy demonstrates a commitment to transparency, honesty, and quality. All those are essential in building trust with users and stakeholders. And then we also want to have regularization and standardization. All right, because having that regulation and standardization across different portions of the industry and across the world make sure that you have like AI solutions that are safe, ethical, and effective. So what do we benchmark in AI and ML? How does one benchmark something so subjective? This is kind of I got into this conversation multiple times this week. Like, if you're doing traditional ML, it's easy to have things that are black and white, right? Decision trees and different ways that you're measuring. I can tell whether something's true or false, okay? If I get a recommendation, I can tell whether someone clicked on it or not. It's very black and white, okay? Whereas, how do you say something is more right when you're talking to a chatbot? It's a very spectrum-based, way to look at this. And I was talking to a customer earlier today, and sometimes you can have something that's extremely accurate, more accurate than others, but like when it's wrong, it's terribly wrong. And that's something you don't want to have if you're dealing with something that's like medical type of advice you're getting. So what are we going to actually test? So again, are we testing hardware? Are we testing the model? Are we testing the data? Okay, let's nail down what we're trying to test. But then from there, what's the granularity? Am I looking at just, something that's maybe such a micro benchmark, specialized and zero in on like individual tasks, offering insights into like computational demands of a particular neural network, like so focused in that sense? Or do I want to look at something that's a little bit more macro, okay? I want to test something with a very holistic view, assessing that end-to-end performance. Whereas end-to-end benchmarks provide basically an all-inclusive type of benchmark of even everything before and after everything that's going on the ML side. There are a lot of AI benchmarks, okay? This is not even like a holistic list, okay? In fact, the list is so long, I put several characters from my daughter's favorite show in here, and most of you probably didn't even see them. For those who don't like Bluey, it's like one of my favorite shows now too. So Mosaic put out a blog. Actually, it's an excellent blog. It's a great read too, okay? And they highlight how they went through and evaluated their benchmark or their models against 39 different benchmarks, all right? These benchmarks, what they did was they separated them up into 4 different groups about how valuable they were. And at the end of the day, what I highlighted here was like group 1. These are the ones that were well-behaved metrics and robust to a few shot settings, okay? Both of these links are great. I made it to the last slide with 24 seconds left. I'm proud of me. All right, a lot of this actually I got from Avi, so and a couple other people. Human evaluations in, okay? Practitioners are growing incredibly skeptical, okay, about some of these academic benchmarks. And some of these are actually falling short over and over again about how they define a new benchmark each year and how people are gaming the system. Sounds similar to what we talked about earlier with Lakehouse benchmarks, right? The Stanford report we talked about earlier, by the way, which they kind of pointed out here as well. That was actually before Llama 3. I'm going to point that out because Llama 3 actually was a pretty good model, but it is not actually reviewed in that one. And then the other piece here is LMSys. Has anybody been to LMSys before? No? If you check it out, it's very like a person. It's more human evaluation. It's actually, you could go in and actually help and be more, it's more like crowdsourcing some of the results and some of the chatbot or some of the LLM tests that they have out there. It's a way to put a human evaluation inside of this. So we are out of time, but I made it to the last slide. Thank you. Are there any questions? I don't have a hard stop. I don't think any of us maybe do.